everyone, welcome back. In this particular video, we will be discussing the problem intersection of two arrays basic. We are given two arrays A and B. What we have to do? We have to write a function to compute their intersection. We have to find the intersection of two arrays. Note that each element in the result should appear as many times as it shows in both the arrays. It means if the array 1 and array 2 have duplicate elements, so resultant should also have duplicate elements. But what should be the number of occurrences? It can be that the first array have some number of occurrences of some element. It can be that second array have some number of occurrences of that same element. But in the resultant, how many occurrences should we need? Let's say in the first array, the number of occurrences of a value v is v1, and the number of occurrences of value v in the second array is v2. So should we take in the output v1 number of occurrences of v or v2? That is the question. That we will see from the sample input output, but let's read the remaining problem. First line contains one integer n, denoting the number of elements in the first array A, and then next n elements containing the first array values. Then similarly, next line contains integer m, representing the array size of B, and then next m elements contains the array elements of B. So two arrays of different size can be there, and we have to find the intersection. Example is, let's say first array is having 4 elements. The elements are 1, 2, 2, 1. The second array is having 2 elements and the values are 2 and 2. How many elements should be in the output? Is one intersection, is one common for both the arrays? No, one is only present in the first array. Is it 2 common in both the arrays? Answer is yes, 2 is present in both the arrays, in the first array as well as in the second array. How many times should I take in the output? The 2 is occurring 2 times in first array, 2 is also occurring 2 times in second array. Intersection is 2 only, 2 times in the output also. But there might be some corner cases. What are different corner cases? First, let's read the constraints. If let's say the n and m are the sizes of both the arrays, it can range from 1 till 10 to the power 5, and the array of I and the b of I, that is array values of both a and b, can be from minus 10 to the power 9 till plus 10 to the power 9. It can be anything in an integer. And checklist is that we have to basically follow which approach. Like you can read the checklist on your own, but output should be in a sorted nature. Output should be in a sorted nature. It is very, very important. So we will see how we can actually give the output in sorted nature in the last. But before that, let me just take two arrays. Let me take the first array. First array and the second array both are individual arrays which are unsorted. So let's take the first array as 2, 1, or maybe 20, 10, 30, 10, 30. Then let's take 50. Let's take 30. Then let's take maybe 50. If this is the first array. Let's say the second array, which is B array, this is A. Let's say the B array is maybe 10. Let's say 30. Let's say 30. Let's say 20. Let's say 20. Then let's say 50. Or maybe not 50. Let's say 40. Let's say maybe 50 only. And let's say now the next value which we are having is 20, or maybe not 20, maybe 60. If this is the second array, we have to find the intersection of both the arrays. So what is the intersection of both the arrays? Is it 20 common in both the arrays? Yes, 20 is present in the second array, but 20 is actually present 2 times in the second array. How many times should I take in the intersection? The minimum number of times, that is the common times. So common, it is only one. Only one time it is common, not 2 times. It is not present 2 times in the first array. So only one time I should take it in the output, 20. Then 10. Is it 10 present in the second array also? Yes. In the first array, it is present 2 times. In second array, it is only present 1 time. So in the output, again, only one time it is common. So only one time 10 will come. And in sorted order, that is before 20. 30. Is 30 present in first array? Yes, 3 times. Is 30 also present in second array? Yes, but only 2 times. How many times it should come in the output? The minimum number of times, that is 2 times only. Minimum of 3, 2 will be 2, because it is only 2 times it is common, and the third time it is not common in both the arrays. What about 40? Is 40 present in the first array? No. Although it is present in second array, but it should be in the first array as well. What about 50? 50 is present in first array 2 times. 50 is present in second array 1 time. Minimum will be only 1 time. So let's take in the output only 1 time. Similarly, what about maybe 60. 60 is not present in the it is present in the second array, but it is not present in the first array. So we have to not take it. So this is the output containing 5 values, and it should also be sorted. We can sort the array in the last, that is not a big deal, but the question is how we can figure out the common values. See, one of the strategy, one of the approach which you can actually use to solve it is find all the possible pairs. And in order to find all the possible pairs, maybe what we have to do is first find 20, how many times it is present in the first array, and then find 20, how many times it is present in the second array, and find the minimum, store it in the output. Then again 10, how many times it is present in the first array, how many times it is present in the second array, and output in the resultant accordingly. This is the resultant array. But this will be a very hectic job. This brute force solution will be very hectic. Why? Because since I will ask for each and every element, what is the frequency of it in the first array as well as in the second array. So for each value, I have to run a loop. So first loop will be for all the distinct values, and second loop will be to find the frequency in both the array. So it actually will go in how much time complexity? It will actually go in at least quadratic time complexity if you will try to use some data structures. But is there any better solution, better than quadratic time complexity, better than n square time complexity? No need to run nested loop. 20, how many occurrences are there? 10, how many occurrences are there? 30, how many occurrences are there? Instead of asking for each and every value, how many occurrences are there? Is there any better thing? Can we just run a loop on distinct values? And yes, the answer is we can store how many times each value is present. We can store how many times 20 is present, how many times 10 is present, how many times 30 is present, how many times 50 is present in the first array and also in the second array. But no need to actually store in the second array. We can just store the frequencies of each value present in the first array in some kind of key value pair. Why? Key will be the element that is for which the frequency is getting stored, and value will be the frequency of that element. That is, example is 20 comma 1. 20 is having frequency 1. 10 comma 2. 10 is having frequency 2 in the first array. 30 comma 3. 30 is having 3 frequency in the first array, and so on. So what we will do in the optimized approach, we will store the key value pair for the first array. Now, what we have to do with that? First of all, let me just make quickly the element comma frequency, that is key value pair for the first array. That is 20 is having 1 frequency, 10 is having 2 frequency. Then similarly, you can have 30 having how much frequency? 30 having 3 frequency. 40 is having no frequency, so we will not store it obviously. And finally, 50 is having 2 frequency. But where should we store it? Where should we store these key value pairs? The best data structure in every programming language to store key value pairs is a hash map, or you can say a map, or you can say an ordered map. The name is different, but the concept is the hashing algorithm. So we can create a key value pair database, or we can say key value pair data store, and particularly the hash map data structure. In that data structure, we can store all the elements along with their frequencies. So initially 20 will be having 0 frequency. We will do the frequency plus plus. Initially 10 will be also having 0 frequency. So 0 will become 1, and then again 10 will come, 1 will become 2. Similarly for 30, initially it will be having 0 frequency. When it will come first time, frequency plus plus. When it comes second time, frequency plus plus. When it comes third time, frequency plus plus. Same goes for the 50 element. We will run a loop on the input array and build this frequency array, build this frequency hash map. Once this is built, now the job is very easy. See, I will now run a loop on second array. Why? Because I want the element to be present in both the array. I will ask, is it 10 present in the first array? Without actually running a loop, I can now ask from the hash map itself. I will now ask from the key value database or data structure itself. Is it 10 present? Answer is yes. How many times? 2 times. I want at least for now 1 time. So yes, since 10 is present, 10 should be printed in the output. It should be stored in the output. So I will store 10. But next time 10 should come. I will say that next time, how many occurrences of first array are not taken? Right now we have 2 occurrences of 10 in the first array. We have matched one of the occurrence of the B with the A. So only 1 occurrence is remaining. So I will do the frequency minus minus also. So when we will have a matching, when we will found a matching, we will print it in the output, we will store in the output, and we will do the frequency minus minus. While running the loop on first array, we were doing frequency plus plus. While running on the second array, the loop on the second array, we will do the frequency minus minus. 30. Is 30 present in the first array? Yes, frequency is more than 0. More than 0 means it is present. So print 30 at least for one time. And since it is matched for one time, what we can do? We can just simply say frequency minus minus. Now only two 30s are remaining. Two 30s are now yet to be matched. Again 30 is coming. Yes, it is still more than 0. So again you can print 30 in the output. Although we do not want output in random order, we want it in sorted order. We can sort the output finally after all the dry run, after all the basically both the loops, that is the loop on A as well as on B. We will sort the array. That is not a big deal. But first let's make the dry run complete. So we have taken the second 30 also because it is also common. And we will again do the frequency minus minus. What about 20? Is 20 present in the first array? Yes, it is. So take 20. And since I have taken 20, it is matched. I will do the frequency minus minus. It will become 0 now. That is, in first array, no more 20 is present actually. So as soon as the second 20 comes in the second array, is there any 20 present in the first array? No, it is 0 frequency. 0 frequency means not present. So this second 20 can't be matched. And if it can't be matched, I cannot take it. So it is unmatched. So do not add it in the output. What about 40? Is 40 present? No, 40 is not present at all in the first array. It is not present in the hash map, means the frequency is 0. So do not take 40 also. What about 50? Is 50 present in the first array? Yes, two occurrences. I can take one of them. I can take one of the occurrences. It is matched. Since I have taken one of the occurrence, I will print it. I will do the frequency minus minus in the hash map. Finally, 60. Is 60 present in the hash map? No. It means it is not present in the array, first array A. So it is not common. So we found 5 elements to be common. Although we found in random order, we have to sort this order. So we can finally sort the resultant array. But what will be the overall time complexity and the space complexity of this optimized approach? Previous solution was taking quadratic time. But since now we are running a loop on first array plus a loop on the second array, it will take n plus n overall 2n time complexity. And what about the space complexity? Since we are going to take the loop, or you can say actually the key value database or the data structure, which is hash map, we have to in worst case store order of n elements. All the elements will be distinct, so order of n elements. And actually one thing we missed in the time complexity, that is we have to sort the output also. So in worst case, if the output also contains n elements, the sorting of the output will require n log n time. So 2n plus n log n, it will overall come out to be n log n due to sorting, because we need output to be sorted. Can we do it in other fashion? Right now we have used hash map. Is there any alternative approach? Although we will not be discussing the alternative approach, but the alternative approach is, instead of making a hash map and then sorting the output, better solution will be, or not better actually, a alternative solution with the same time, same space will be, make a sorted kind of hash map, make a sorted kind of map, that is sorted kind of keys. If the all keys will be sorted, then it will actually help me to produce the output also as sorted, if all the keys will be sorted. So one alternative approach which you can discuss, or which you can basically try to solve on your own as a follow-up, can be using tree map, or it is known as a sorted map, or it is only known as map in some languages. So try to use a tree map, try to use a binary search tree, that is a sorted hash map kind of thing, where all the keys will be sorted. But this solution which we have right now discussed using hash map, that is using key value pairs, will be suffice in all of the languages, all of the programming languages actually. So we have discussed the approach. Now what we are going to do is, we are going to come up to the third milestone, that is writing the instruction manual. As you can see that we will be given both the arrays and the sizes of both the arrays, and in the output we have to return the intersection in a list or in an array. So what we can do is, we can initialize the resultant array list, the resultant list of integers, so that we can store all the values in that, and it will be a dynamic array obviously. And just initialize a data structure, create a integer versus integer data structure, create a hash map of what? Of key and value as integers, because key will be the elements of the array which are integers, value will be the frequency which also is integer. So key as well as value will be integer. So create a hash map or empty hash map. Now run a loop on the input array, on the first input array A. So run a for each loop probably on first array, and we will get every time a element using a variable element. That is, every time we will get the value directly, element. What we will do with this element? We will do the frequency plus plus. So put the frequency of element in the hash map by plus one. Put the element of frequency in hash map as old frequency plus one. Now, what is old frequency? We have to actually get the old frequency. So get the old frequency of element from hash map. And if it is not present, we should take it 0. So in the bracket, I am writing 0 as default. If it is not present in the hash map, it should be 0 by default. That is not present at all. And then put it plus 1. That is, do the frequency plus plus एक तरह से. Once we are done with the frequency hash map, once we have made sure that we are having the frequencies of each and every element, we can run a second loop, that is a for each loop again, over the second array, on the second array, using again the same variable name, that is element. But this time we will actually create the resultant. So what we can do is we can create the resultant array list before the second loop directly, because we will be using it in the second loop itself. What we can do, first get the frequency of the same element from hash map, and if it is not present, we have to take it 0 again. When do we have to put it in the resultant? We have to put it in the resultant if this frequency is positive. If the element is present, then only put it in the resultant. So if frequency is more than 0, then add element in the output. And also do one thing. What we have to do after adding the element in the output, we have to do the frequency minus minus, because the element now will be, one of the pairs will be matched. So remaining pairs we have to match now. So put the element frequency in the hash map as the frequency minus 1, the old frequency you can say minus 1. Otherwise, if frequency is equal to 0, do nothing. No need to do anything. Finally, output should be returned, that is return resultant. But before returning resultant, the, we can say, resultant should be sorted. So sort the resultant array list or the array using inbuilt function. Every language have some inbuilt function to sort dynamic arrays. So you can sort the resultant before returning it, because it is specifically mentioned in the output format. Output should be sorted. So this is the pseudocode, or this is the instruction manual of the problem intersection of two arrays. We will be doing the code in Java. What we have to do is we have to create a hash map of key and value both as integers. So how we can create a hash map in Java? We can say hash map with H capital, M capital, angular brackets, integer comma integer. It means the key is integer, the value is integer. Let's say the hash map name is HM is equals to new hash map, angular brackets, and the round bracket semicolon. This is how you create an empty hash map in Java. Once we have created an empty hash map, a key value database or data structure, run a for each loop on a variable element on the first array. So for int le colon a, it means run a for each loop on the first array. And then what we have to do? We have to first get the old frequency. So first, let's say old frequency is what? Hashmap dot get is the function name to get the old frequency of the element. But according to the question, it is, according to the instruction manual, actually it is mentioned that if the old frequency is not present, if the element is not present, in some languages like C++, it will give you 0. But in Java, if I want to take 0, I have to use get or default function instead of get function. And this get function will run in constant amount of time. So what will be the default value in the second parameter? It will be 0. The second parameter means the default value. So get the old frequency and now put the old new frequency as the hm dot put the element with the old frequency plus 1. That is frequency plus plus actually. So in some languages, you can simply do hm of square bracket element plus plus, but in Java, you have to first get the frequency using get or default, then put the frequency as old plus 1. Once the hash map is filled, we can ensure whether the hash map is properly filled or not by just printing the hash map itself. Let's see what is getting printed. For now, we have to return something. So we will return an empty array list. So that is does not give me error that we are not returning anything. So we have returned something, but the main thing is whether the hash map we are constructing is correct or not. So for the sample input in the hash map, actually we are getting 1 having frequency 2, 2 having frequency 2 for the first array. Yes, the hash map is working properly. Now what we have to do? Now we have to initialize the resultant of integers. List of integer result is equals to new array list, the array list integer, so that we can store the intersection values in it. Now run the loop on the second array because we have to find the intersection in both the arrays, a for each loop particularly. So run a for each loop on the second array, but this time get the frequency from the same hash map. So you can say frequency dot hm, frequency is equals to hm dot get or default the frequency, which is of the value, what, of the value element, and the frequency, if it is not present, it should be taken as 0, the default. So what is the frequency? If it is greater than 0, then only take it. Otherwise, do not take it. If it is greater than 0, then what we have to do? We have to do two things. First of all, take the element in the output. So result dot add the element in the output, but also put the frequency as -1. So hm dot put the element with frequency -1. That is decrease the frequency because one pair is matched. If I will not sort the array, if I will directly just return the same array, let's see what will happen. Like there is one point remaining from the instruction manual, which is sorting the resultant array. But for the sample input, it is actually working fine. But what will happen if the first array is having four values, 1, 2, 3, and let's say maybe not 1, 2, 3, 1, 3, 2, 4. And second array also having four values, which is 1, 4, 2, 3. So intersection should be 1, 2, 3, 4 itself. All the four values should be the intersection because it is present in both the arrays one time, the same values. But output we want is 1, 2, 3, 4. Output we are getting is 1, 4, 3, 2, 3. A wrong order. Why? Because we need sorted order. So in order to sort, what we can do, we can just use arrays.sort, and actually not arrays.sort. Since it is a list, in order to sort a list in Java, we have to use collections.sort because list is a collection. So collections.sort the resultant array list and then return it. So sorting will actually require n log n as discussed in the approach video, and the get function, the put function, all of these functions in average case takes constant time. So this overall loop will be linear because inside that loop the functions are constant. This loop will take linear time. So linear plus linear will be 2 times linear, but the sorting will take n log n. So overall time complexity will be n log n because dominating is n log n over 2n. And the space complexity, since we are using a extra data structure, a hash map, we are using some extra space of linear order. So that is all about the time complexity and the space complexity. Let's wait for the correct answer to get displayed to whether we are able to satisfy all the test cases. Yes. So that was all about the problem, intersection of two arrays.